Hey everyone, so this is kind of a ventilator design that I put together. Decided to give a try at keeping it simple. So this is all PVC tubing and a couple of valves. This is of course an air compressor. You've probably seen one of these before. Right here, this is just for convenience in terms of giving me an extra shut-off valve here. But this needle valve is here to control flow rate, and you'll see that in just a second. From there, the compressed air inlet goes to one valve here in the final design that will be either replaced with a solenoid valve or simply motorized. I've got a adapter for a hobby servo that just finished printing and is gluing up now. So we'll see that in a second, but this can be any type of valve that you can open and close on a timer. From there, this is going into this little vessel here to this down stem so that it bubbles up through the water. Now, if this was actually in use, you would want to have this inside of like a pot, just like a regular like cooking pot, on a hot plate to make kind of a double boiler setup that will let you very carefully and finely control the temperature in here. And the purpose of this is to warm and humidify the air, just like you see on a lot of the older designs like the Emerson. From there, there's a short stem on this side that goes up and around and into this main manifold, I guess is what you would maybe call this here. And then from here, it splits off to a few different directions. Right here, we've got a downstem just going into a bucket of water. This could certainly be made more compact, maybe replaced with a mechanical release valve, but this is just a constant pressure relief valve. Basically, and this controls your PIP, your positive inspiratory pressure. So this is the maximum pressure that the system will ever reach, is controlled by this. From here up to there, you've got your patient breathing tube. As you can see, we've got a very sophisticated artificial lung here. The beverage containment module here is just to prevent the I'm sure you've all seen one of those from just continuously inflating forever, because it'll keep blowing up and not build up any pressure at all. But anyway, so yeah, artificial lung, real fast, real easy. And this is just to hook up to this pressure gauge right here. And the only kind of modification to this, other than standard PVC fittings, which you could use standard PVC fittings for this, is this little tube right here. Just drilled and tapped that with a NPT tap. Going to hose barb. Again, these fittings can be whatever you have lying around. They don't have to be exactly like a 1/4 inch hose barb. And this goes up to your second and final valve. And this right here either allows or shuts off airflow to your PEEP. And this is exactly like on the other side. This is just a adjustable height PEEP right there. The deeper it goes, the more your PEEP pressure. And that's the whole system. If this was going to be run like actually on a person, like I said, these would be replaced with just electronic valves. Those could be solenoid valves, those could be pinch valves, whatever. If using solenoids, and really just in general, you would want both of these valves to be in the normally open type. If these fail open, then the patient is still like able to breathe, because there will be air incoming through the regular pathway. So this one is especially important. You want this to stay open. The only real reason to have this is to kind of prevent you from wasting too much oxygen. So this could even be completely eliminated just for the sake of simplicity or safety. And this is the only one that really matters in terms of functionality, in that this will either basically switch it between going to the PEEP or the PIP. So anyway, yeah, that's the system. Let's go ahead and give that a quick run. And I'll keep an eye on this here pressure gauge. So inspiratory cycle, we're going to be turning the PEEP off, and then we'll just open up the main airline. As you can see, that is bubbling through, and the pressure is rising in our artificial lung. You can see that blowing up a little bit. And at a certain point, you will see, there we go. Now we have some bubbling through the pit line. As you can see, this is settling right around 27 or so centimeters of water. If we wanted to adjust this, let's say to, how about 25? That's a nice number. Totally arbitrary. And now you can see we've got 25-ish, close enough. And there we go. So this is our inspiratory pressure. Now we need to let the person exhale, so we just turn this PEEP valve open. Everything escapes through there, and whoop, auto shut off went on. And now you can see we're keeping at a constant 8.3 centimeters of water for our PIP. Let's see if we want to take that down to 5. That's a little bit high. Again, we just raise this guy up. And now we can see it's settling right around 5. So like I said, you can use this to just turn off the flow to the oxygen. Since these pipes aren't actually connected to anything, or aren't actually properly sealed, then that is going to slowly drop down to atmospheric pressure. That's just because I haven't glued these fittings together or anything. They're just kind of shoved in there. But in any case, that should, in theory, hold its pressure. In actuality, you might want to just kind of leave this on. Maybe even have a separate, a Y connector here, and then a separate needle valve to keep at least a little bit of pressure flowing constantly. And that, if the system fails, will allow the patient to still, breathe. So, yeah, there's that. And again, if we want to switch it back to an inhalation cycle, all we do is close that valve. You can see pressure building, and PIP letting off pressure. And then we can just go back to an exhalation cycle. So this is a very simple system. You actually really only need one valve, one electronic valve. It's about as dead simple as it gets. You control the rate of inhalation through just your needle valve right here, which would typically, I guess, be like a flow meter or something. That's really all there is to it. Like I said, I definitely am a fan of the Army emergency respirator, and I think that is definitely worth pursuing further. But I wanted to kind of get this out here as just a rush to something workable, because this will work today and is fairly inexpensive, fairly simplistic parts, just an Arduino or any kind of microcontroller really, and something to turn this. And that's all you need, gentlemen. All right, thanks for watching.